back again. So my plan today is to run through. Well, first let me just introduce this website. So exploit.education is this cool site that has a bunch of challenges to learn about software exploitation, I guess generally. And so there's different sort of courses or I guess tracks maybe is what they call it. Phoenix is the one that I want to look at. It's got networking, stack overflows, format string vulnerabilities, heap exploitation. I think the plan for today, what I want to try is to see how much of the stack overflows challenges I can get through. I did do this like a year ago, but I don't remember how I did it or really like any of the solutions. So I think it could just be a fun thing to work through live. And so hopefully even like, there's no one really here right now, but the VOD maybe. Oh, what's up? We got one person back. Hey, how's it going, man? So yeah, I'm gonna just try to work through Stack Overflow challenges and see if I can get through all five. And yeah, so the cool thing is they give you the source code, and you compile it yourself, and then basically just try to exploit it on your own machine. So I already like downloaded these web pages so I could do that. So this is the first one. And so let me copy this source and I'll make a file for it. Let's see, so stack 0. Let's call it challenge.c. Okay. And then I think, yeah, they have this level name thing. Whoops. Of him. I'm just gonna paste it again. Cool. So this is stack. Oh, haha. My brain is. Thank you, sir. Or ma'am. I don't actually know. But yeah, that was the wrong one. Let me take a look at stack 0. So it should be a little bit easier. Yeah, you're right, because yeah, anyway. Okay, so this is stack 0 challenge. And I don't know, we'll just modify it like inline here. Let's do that. Okay. And so first, just kind of take a look at the code here. Okay, so the first thing they do is they set up a structure with a buffer of 64, and then there's a volatile int change me. Okay, I wonder what that's gonna be about. So prints the banner, change me set to 0, gets, that's a no-no. So okay, and then locals.changeme doesn't equal 0. Okay, so this is really all about, I think, so the gets function is dangerous and should never be used. I'm pretty sure the compiler will tell us that when I try to make this. But effectively, I think what happens here is memory is going to have the structure laid out, and it's going to have 64, or a buffer of size 64. And then next to it's going to be memory designated for this change me variable. And even though this is so gets is gonna get character input from us, like, so I can throw in text at it, and it's gonna try to fill this buffer, but there's no bounds checking on gets, and so we can just throw as much as we want at it, and it will eventually overflow or change this change me variable so it won't equal 0. So I think that, yeah, stack 0. This one's pretty easy. So first let me compile it. I'm gonna do 32-bit only because if I do 64, the later challenges might get a little hard. I'm not the best at this stuff. That could be a concept for later, but it won't really matter, I think, until like the later challenges. So we do need to, because all of this stuff is well documented and known, like, how is it easy? Yeah, I know. Well, everything is relative. It's ridiculous, man. The return oriented programming and stuff, it's like next level. So I'm just trying to start with this and get my way get my way there. But yeah, to even compile this code so that we can abuse this vulnerability, we effectively have to force it to be allowed. So we have to give in this exec stack, and I believe there's another flag for fno stack protector. And then stack 0. Yeah, I got that one wrong. I forget what the exact syntax is. Fno. Oh, there's no G. That's for debugging symbols. Right? Let me look it up. So you have to turn off the stack protection. Fno stack protector. Okay. And then Z exec stack. Yeah, GCC. Z wait. Let me get rid of this -G. An M32 should specify, I think, 32-bit. So fno stack protector. What the fuck? Did I do something to my GCC? Oh dear God. Oh no. This would happen, of course, when I'm like streaming. I was playing around with something and I might have which GCC? I guess maybe before I can just try to compile it without all these flags. Stack 0. Alright, so it is something with my flags. We definitely know fno stack protector and Z exec stack. Okay, I must have just had a typo or something. Great. So if we run this, we'll see the welcome message, and basically now it's waiting for our input, right? And so I can just break this by throwing in anything bigger than 64. So I think, for example, let's see. I think one way I could do this is it might be more. It's probably gonna take like 65 or 66, maybe. I'll just go to 70, just so we can see how many actually got it correctly. So we'll do Python print I times into the stack 0, and then I think we also want to know Testing, like what, how many letters we sent in. And this needs to be in quotes. Well, no. For loops in bash. I forget how sometimes the right, so that doesn't work, but that works. Okay. Times actually, I don't really need to do this. I think what I can do is just open Python and print. Let's print just 64 A's. Just to, because I think to get full closure on this, we should see exactly how many it took. And so if I run S0 and I give it why is it not waiting for gets? That's weird. Yeah, that's how that's supposed to work. Okay, so 64 A's probably won't do anything. But if I add just 2 A's, it does. Let's see. Yeah, even just 1 A, so 65 A's. Yeah, so for this very simple challenge, effectively all we want to do is change this this int that's part of this structure that's set up in main, and they give it a 0, and we want to not be 0. And so by passing in, it looks like 66 A's. We do change it. Oh, actually no, did 65 work? Yeah, I guess 65 was enough. So let's move on to stack 1, because this is where it's going to get more fun. Stack 1 is the same thing, I believe, but now instead of just changing it at all, because before all it cared about was that we changed it to anything other than what it was initialized as, basically just proving that we like did what you just said, that our character input actually changed the data that the program set up, right? So it initialized change me to 0, and then because we see this, it's now 41 probably because we made it A. The next challenge though, so now we need to make it equal this. So we already have some sense of what we need to do. It's going to start with probably 64 A's, and then just tack this on, I think. So let me go back to Python because it's easier to build these sort of things. So I think so first we need to see what this is. This is a hex value, but we need to see what this is in like the character input of it. YB. Interesting. Did I not? I feel like I would have thought it would be like a word or something. Okay. So, and then I think what we also need to do is reverse this, the order of this, because in memory things are going to be laid out in reverse byte order. So like if I pass in 1, 2, 3, or I guess maybe that's not a good example, but if I pass in something like 21, 23, it's going to be read as 23, 21. So I think we can just flip it like that. So I think an initial payload to try this would be A times 64 and then plus this effectively, which is this when you make it a character. Okay. So I'll make a little directory for stack 1. Copy this code. Make stack 1. Oh, I always do that. Just change the level name. I think we were doing that format. Then compile it. So we gotta let all of these fno stack protector stack 1. This is what I was getting before. I don't understand. Is it one of my flag? M32 exec stack Z exec stack fno stack protector. I don't understand. Isn't that the same syntax I used over here? Oh, is it the 32-bit thing? Oh, it is. Okay. GCC 32-bit. That's not really important, but I guess I will check that later. Yeah, okay. So, let's see if this payload that we made works. So I'm going to use the debugger. GDB is like a pretty classic debugger for this kind of thing. And then we can take a look at, oh, I need to compile this again actually with debugging symbols so that we can put breakpoints and stuff. Okay, GDB, disassemble main, file S1, disassemble main. Cool. So we probably want to put a pause right after this. Oh no, this is stack. We probably want to. Oh, this time it's using stir copy. That's interesting. Oh, we have to provide it as an argument this time. Okay. That's okay though. They're still not doing any bounds checking, so I think the exact same problem applies. So in the previous code, the reason we were able to change this is because this gets function doesn't check like what did is this actually only 64 characters. Similarly, the second challenge, they're not using stern copy, I think would be how people call it, with the N, because then you would specify, oh, actually I only want to read comma 64 of this, but instead this isn't going to check like fgets. It's not going to check how big this is and what we actually did, so we can send in something. So I think where we want to break is probably here, so we can take a look at what we made the change me variable. So yeah, when you're disassembling something, obviously you're looking at assembly code. It's not a one-to-one translation of what's on the left. But some things can be helpful to kind of pick out where you're looking. So for example, call means that it's probably calling some external routine, right? So like printf is going to be a call to something. Stir copy, that's a call. Puts is a call, that's a call. But something like this, locals dot change me equals, is going to be more like a compare instruction. And it looks like, because we know what's trying to be compared for at 49 6c blah blah blah, we can find that's right there. So I could put a breakpoint at main plus 101 basically. I don't know. So this address on the left is gonna change because we haven't run this yet. It'll become something different. Plus 122e. So maybe I should just do that actually. Okay. And so now if I disassemble main, right, we have this. So this is where we want to break. And then I think what we want to do is run. Can I cat the payload? Let me just quickly check how to do this. I think you can run commands within GDB. Commands within GDB. I think it's just... Oh, let me turn on some music or something too. Why not? Does it let me? No. I just want to be able to, because this is, I don't know if this is going to be printable. Oh, okay, so we're lucky. Right now, this is still printable. So I can just run this. I don't need to waste time. I can just run this with this argument. Some of these things are going to become not characters that I can copy and paste. So that's why I was looking for this. But forget all that. So yeah, let's see what we get when we change this. So we have 64 A's and then basically the equivalent of this hex value in characters but backwards. Cool. And now we're stopped at this instruction. So we've already done the copy from buffer, and it's checking right now if that variable equals this hard-coded value. And it looks like 49605962. So we might have gotten it the first try. Let's see. Yes, it worked. What do you know? So I think that was clear. Hopefully. I guess on a stack too. Okay. So similar, we got this structure again. It's got a buffer. It's got a change me variable. Sure. Is that music that you made? Ah, sure. Yeah, I got no attachment. I just put on something random. Let's see. I don't know if you can hear it actually. Oh, no, I think you do. No, no, no. Can you hear what you're... Can you hear the music? It's cool. Nice. Yeah, that's what I thought. It's oddly high for me, but low for... Alright. Try something. Ah, I think that might be it. Do you hear it now? Cool, cool, cool. Word. Alright, so I think this one for stack 2 is actually very similar to the last one. It's going to have a string copy again. The difference is that I think we're just changing an environment variable and going to use that to overflow. So the first thing we need to do is get what is this. So target equals oh, those are not good characters for printing. Okay, that's fine. And then I think again it's just 64 A's plus this, because this is really unchanged. It's the same thing. Now I don't know if we're going to be able to print that though. What we can do is so what we can do is say okay, and now we can set this environment variable with what we just built here. So this in reverse byte order after 64 A's, so that we're filling this. So we can do export exploit education, and then make that be the result of that. So if we wanted to see what is this, we could see that as that. So if we run, so let me make this, let me compile this now. Okay, GCC C stack, no stack protector, and then stack 2. I'll call it S2. I think we can just run it now because we've made this. I've exported this variable. Great. Might have been a little fast, but you can always watch the VOD if that didn't make sense. Cool. So I think maybe we should move on to the next one. They're gonna get harder, and I'm gonna get increasingly less good with finishing them efficiently. So stack 3. And again, this is something that anyone can check out. Exploit education. I think it's exploit.education. It's Andrew Griffiths. It's been around for a very long time. And yeah, there's a bunch of things. They do stack stuff. all the way up to like heap and network. Yeah, pretty advanced stuff. That was a cool song, by the way. I haven't heard something like that. That was very interesting. Ah, okay, so here's where it starts getting hard.
This is Diego.
Hi, Diego. It's Jennifer
Ah,
Coolidge. You know,
no ads. No ads allowed. I don't like ads. So this one actually, this is where it's gonna get a little bit trickier, I think. Um, so they're easing us in because we have this Nadas challenge. I don't know if I know. If I know of that. There's a lot of these sort of like crack me, hack me kind of things. So um, yeah, I don't know if I actually know of that. That's kind of cool. Uh, is it like similar with like sort of simple programs that you're given the source and then you have to sort of break it? So yeah, so for this one, oh, it's dedicated to web. Ah, yeah. I will say I try web stuff, but I'm not the best at it. Um, I'm not really a security person. This is all just for fun, like in my off time. So that's cool though. I might have to check that out. Always looking for new ones. Uh, yeah. So I think this will be very doable, but it's gonna change focus a little bit. It's gonna get a little bit more abstract because in the prior examples, um, all we're really doing is like this is all just in memory, right? If we were to look somehow at like a block diagram of what this struct locals is, this buffer is right next to this change me thing, right? Um, and so all we were really doing is just going, oh, we can't see my hands. All we're really doing is just going past the 64 to sort of just directly change this. Um, where this is going is actually going to be how the program operates. Um, so it looks like what they're doing here is we still have the buffer of 64, but now instead of just holding a variable like 0, it's holding a function pointer. And they're going to initially give it a null pointer. So, if you were to run this program, the intention would be to have nothing happen if you were to say call locals.fp. But the goal is, well, if we're allowed, we have control over this buffer, can we give it something to where when it runs, actually it's going to run the congratulations, you finished the challenge. So that's kind of cool. So now we're changing, I guess you could say, maybe execution of the program, how the program's actually going to run based on what we give it, right? Otherwise, because it would never get to this complete level unless we pass in the exact right address for complete level. So I will build this. This is stack 3. And this time I definitely need to define level name because it's referenced somewhere, so I can't just cheat like I was. All caps, why not? Let me we gotta do z exec stack, no stack protection. Oh, and what? I think it's what is the format for? I thought it was just -m. I don't know what I did wrong. It is -m32. Weird. Huh. I did something to my GCC, I think. I don't know. That's weird. That will make things a bit harder later, but it's still for now not gonna matter, I think. Okay. So the first thing we need to do is we need to figure out, well, okay, where is complete level? What address do I give it, right? That's the first question. I can give it buffers, or I can give it anything. I have control over the buffer, but what value is going to point to this at runtime? And that's where, again, GDB is going to come in handy. And by the way, I'm using GDB with enhanced features. It makes it a lot easier for these kinds of challenges, because when we run things, like I think I can show you, or over here, you can actually examine not only line by line. Well, you can do all these things in GDB, but it's not going to be in one screen like this. And so we can see a lot of good details and important information. So yeah, I would recommend, it's Hugsy GDB enhanced features. It's a really cool, really popular thing. So yeah, so what do we give it? That's the question. I could say disassemble complete level. Actually, let me run it once. And now I'm going to say disassemble complete level. And we should see, or even if I said break complete level. Ah, okay, so now this tells us that's the address at runtime of that level. So, kind of like we did in the past, I can just basically create a payload where I say the target is this memory address. Ah, okay, so 1, 2, 3, 4, 5, and 6 bytes. So we'll have to experiment with it. But I think in the past we were only overwriting. Well, it didn't matter necessarily in that case, but I think in stack 3 we were only overwriting 4. So that the offset, the number of A's that we send in, is probably going to have to change. Yeah, 1, 2, 3, 4. Yeah. Yep, 4 bits. Or 4 bytes. Oh god. Four bits? I always get confused about the bytes bits distinction. I mean, either way, we'll just. I'm an experimentalist, so I'll find the right answer by trying. So we want to flip this. We want to append it. I'll start with I think we have to subtract it by 2. I'm not positive, but we'll see what happens. And let's see, we're not using environment pointers this time. Good. Okay, great. So in that case, I'll write this to a file, and then when I run it in the debugger, I'll just like pipe that file content to the debugger. I guess also we want to figure out where to break in main. So I guess we're looking for another compare, probably, or if locals, let's see. Did I guess maybe where it nulls this is the easiest thing to find. Or they call it gets. Standard out. That's the print. So I think that's the call to the printf of the banner. That's probably the call to get the local buffer. Oh, maybe not. So this could be the printf here actually. Test RAX. I think maybe this is probably the... Well, let's see. Okay, let's write this into a file. Oh, off by 1, huh? I'll just call it payload 3. I don't care. Okay. And we can run with payload 3, so this will pipe it right in. And because this program is just waiting for input, it'll just get that payload. Okay. Ah, so it looks like we did change locals.fp, but what I did was exactly wrong, I think. I think I changed it by, I shortened it by 2 bytes, and we lost the 51D1. So this won't work because it's going to call a function that doesn't exist at 555555. Yeah. Yeah. Yep, classic. Not a professional. Okay. But now we did overwrite this, and as you can see, because of GD, the enhanced features, we can even see, oh look, that's pointing to complete level. So yeah, so I guess I shouldn't have touched anything. I should have just left it 64 and just played it as is. Yeah, and so when I hit continue, what we'll see is, actually, let's step into it, right? So step, oh, it is equal. It's going to call, so this is a printf statement basically telling us what's going to happen there. We can look ahead at the instructions that would run next. And I think this is probably where it actually runs, because it's basically just calling what's ever left in the register. So we can break after the printf. So continue. So let's see, it probably told us something, calling function pointer 555d1. Great. And now we can see, yep, it's going to call the thing that we passed in. So I continue. Congratulations, we finished level 3. Excellent. The speed of solving these is going to go down exponentially now, though. Because these, I understand these initial concepts well, but it gets very difficult for me as we get harder here. Alright. And again, the VOD, I'll leave the VOD up. I think this is kind of good. You know, if I can figure it out, hopefully you can figure it out and just follow along. I'm not using too many fancy tools. Everything here is open source, free, very widely available. So it shouldn't be like hard for you to replicate what I've done. Yeah. Yeah, that's definitely the next step. And I did look into, I started building a Discord. So probably next time I stream, I'll like share the link to that. Not too many people, but you know, you gotta start small. But I do think it's like, it's important to have this sort of information out there, because not everyone can afford college, and I don't even know if this is taught in college, to be honest. And I think the more the merrier, you know. Doesn't hurt, as far as I can tell. Yeah. Thank you for being here. How's your good time zone? I don't know where you're from, and I don't want to ask. You don't need to tell me. But hopefully you're having a good time zone wherever you are. Absolutely. I'll probably end up once I've done a few of these, I'll probably make a YouTube channel and like throw the VODs on YouTube. And yeah, it won't all be cybersecurity either. I think there are some other things I want to do, like sort of live coding and developing sessions on projects. So like I had some ideas. Oh, it's late for you. Okay, or early. Okay, cool. Well, hopefully you're either just waking up or you're relaxing, ready to go to sleep. Yeah, so, but yeah, I will make a YouTube channel probably. And yeah, the content won't just be cybersecurity stuff. The thing I wanted to work on was like a super basic augmented reality, like baby's first AR. Yeah. Well, I will say it's important to underestimate myself. At least it seems like it, because this stuff gets really wild. They get real hard, like really fast. So I have a lot of respect for the people who do this kind of stuff, because it gets really crazy, really crazy. So I have to humble myself. Yeah. But you know, well, yeah. Thank you. Everyone is smart in their own way. I'm a believer in that. I feel like you know, it's set up so that certain types of smarts gets you really direct results, right? Like if you're a really good people person, that's like great for getting hired. If you're really good at math or really good at but I think everyone. Oh, thank you. I respect you too. You're very polite, and yeah, thank you for showing up. So yeah, so stack 4. I think we'll be able to do this. Oh, they've been having things at the top the whole time. Stack4 takes a look at what can happen when you overwrite the saved instruction pointer. Standard buffer overflow. Okay, so it's gonna get fun now, I think. Ah, yeah. So okay, here's where it gets different, and I'll point out the difference to you because it's kind of subtle. And a lot of these things, I feel like they don't get explained very carefully. But in all these other cases, this code is kind of built for us to break. We're not really breaking anything, right? Because yes, the locals is set to null, and the code doesn't actually change this int FP. Like, so we have to change it by using the gets in a way that's not good, but at the same time we didn't really change any like this if statement checking local FP calls locals.fp, right? So the code kind of nudged us along. It helped us jump in here. But in this case, there's no check on gets buffer. There's no is it, you know, it's just gonna call whatever's there. And I do believe this means we have to be a little bit more careful. So there's only one way to start, and that's just to get rocking. So I think in this case we probably don't, I don't know if it matters if it's A or not. What I'm gonna do is use x90 because that's the no operation character. That's this hex code translates into basically do nothing for the code. And then I guess no, we need to see where this complete level. So that part remains the same. We do want to jump into this somehow. We're just not actually being given this code isn't calling that function, right? There's no, unlike this, right, where whatever locals.fp has, it'll get called. There's no such thing here. This is not, you know, buffer is not being called necessarily, as far as I understand, right? So start level will be returning to, oh, built-in return address. So maybe actually it's not quite what I described. Okay. Either way, it's going to be very similar to what we did last time. So, yeah. So let me build number 4. Call it S4. Yeah, again, this this is like a very outdated thing, right? These are all like very well-known things, and even just building this, right? Like we have to really force GCC to even let us do this thing. But it's still useful because even the modern exploits, I think, fundamentally are sort of relying, you know, it's all kind of like it builds upon stuff. So understanding this for defense or offense, really, I think is pretty useful. So yeah, let's open it with GDB. I'm just gonna run it once so the addresses are that's funny actually. Is that it doesn't not null it? Whatever. Okay. Break or disassemble complete level. Okay. So this is where complete level starts. So I think I might naively do what I did last time effectively. And see how it differs. Because I think it's gonna be fundamentally similar but just subtly different. Disassemble main. Alright, this time it should be easier. So call start level. So actually we need to look at start level. Let's see. We'll be returning to. So I think this is probably the call to gets here. So I think it's setting up the buffer here, and then it's calling gets, and then probably this is the print statement. So I'm gonna try to break it here, and we'll run with payload 4. I guess my background makes it kind of hard to see these. I'll watch these VODs and see how I can improve this. But yeah, so let's see. So what did I give it actually? I gave it 555555551A9. Okay, so this is fgets. And I think we care about after fgets. I'm gonna delete that first breakpoint. I'll just leave the second one. Okay. So now we're stopped in start level. Oh, is it at the same point? I'm confused. Let me try that again. Okay. Is this printable? No, it's not. Let me see. Five, 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 two, three. Okay. So I think what I want to do here is try something different. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. I'll just count it after. Is that? I guess I can probably do special symbols too. Yeah, that's plenty long enough. Oh, right. 62. Yeah. I should have. Basically, I just want it to be longer than, significantly longer than, I guess, 64 plus 6, I think. Yeah. We'll figure this out, I'm pretty sure. So, because I'm curious basically what this value is going to be. Like, it should end up probably being a bunch of random letters, but I guess where it does that is somewhat like unknown. I should point out this is a crude way to do it. There are tools that will help you do that. There's like pwn tools, for example. You can use the cyclic function. But I like how this is sort of, for like educational purposes, I feel like this might make sense in some ways. So, yeah, let me try to do run with payload. Okay. I see what I'm doing wrong. It's gotta be a lot more than 64. Yeah. Yeah. Okay. So the problem is we have to overwrite the instruction pointer. And that's not what's happening. Basically all I'm doing is clobbering this void return pointer but that doesn't actually. Yeah, that doesn't jump us into complete level. Okay, I see what I'm doing. So this is where it's like, yeah, this is starting to become more realistic, I think. Okay. So basically, we need to see how much junk. So I will use cyclic, actually. So, breaker. Way bigger than it needs to be. So basically, we want this to segmentation fault because ideally we've overwritten, right? So this is what the register, the instruction pointer. This register holds the instruction pointer, so it'll point to the instructions for the computer to like the CPU to execute. So right, I don't think my breakpoints are in the best places, to be honest. Yeah, I don't really care about that. So now I'm just throwing in, it's only a 64-bit buffer, I'm throwing in 4K bytes. I'm throwing in, or 4 kilobit, this is where I'm dumb. But I'm throwing in 4096 bits, so it will definitely break. Yep, so we get a segmentation fault. Right, and so now the stack pointer is pointing at garbage, right? And the base pointer pointing at garbage. So really, yeah, the buffer's been deeply abused. Buffer's crying right now. So I think what we want to do is we want to find where that is. So offset equals breaker dot find that pattern 88. Okay. So can I just give it I don't know. See, this is where I don't remember how to do the first couple. I kind of remember, like, vaguely how to do it. This is where I'm gonna have to pull a little bit. But I think what's happening is we can do how many? 1, 2, 3. Oh, that was well done. So with Pwn tools, you can basically convert this hex address. Yeah, I can do it. Thank you. So Pwn tools, you can basically just convert this, kind of like what I was doing manually before, like when you saw me do this, all this junk. I can just toss in this address and Pwn tools will flip it and reverse it for me. Yeah, so let me try to write this, see what happens. I don't know if it will work. The issue here also with the 64-bit is these zeros. So luckily these zeros are at the end. Fgets will read until it sees null terminated. Because a string is really defined as something with So like a C program will read this as an A because it sees, oh, there's a 0 at the end, right? So it knows where to stop, and then you get A. If this is in the middle of something that I'm trying to send, fgets will stop. But luckily, I don't think it matters in this case because the leading zeros. Well, we'll see. We'll see. That's why I wanted to do it in 32-bit. Okay. What did I call that? I called it breaker again. I guess it's not really gonna. Oh, it'll probably break it. That doesn't look right. Wait. I was just printing something still. Turning to 61s. Oh. I think maybe I shouldn't have looked at the stack pointer. I think I should have looked at the base pointer. I see. So yeah, what happened there did not work. Stack pointer is still pointing at garbage. Base pointer is still pointing at garbage. Wait, that actually doesn't make sense. That didn't run the file that I gave it then. I didn't have garbage in this file. Streaming things you don't know how to do well is hard. Alright, now let's see what happens. Oh shoot. I actually solved it. What do you know? So I think I should explain what we did there then. So yeah, so when we ran breaker originally, right, it was just a bunch of stuff, abused that buffer, which gives us, so we end up seeing, oh, okay, we have control over the stack pointer. So we found that this was exactly 88 into the 4096 nonsense we sent in. And so we just change basically the end, right? So we give it 88 plus the address of what we know to be the win function, the complete level function. And so I think I'm not sure how to break through. But yeah, so effectively what's happening is instead of jumping to 61, 67, whatever, blah, 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 blah. Right, so it was trying to jump to this. And basically we just said, okay, if we change this stack pointer to actually point to complete level, the code will jump into complete level and finish. And that's what we're seeing. So level 4 complete. Very nice. I know one of these got me for a very long time when I first did it. Maybe I am underestimating myself a bit, but I think this is the one that got me for a long time. Like I said, I did this like probably a year ago, probably maybe longer. I just don't really remember what I did fully. So this, okay, this is like a classic. This is basically like an example of what would happen in the real world on this level. And I'll read their thing because it's pretty good. So as opposed to executing an existing function in the binary, this time we'll be introducing the concept of shellcode and being able to execute our own code. So that might be abstract, but basically the goal here before was to, in all of these cases, even just now, just move something towards an address of an existing function, right? But what often happens in the real world during attacks, right, is some code leaves this in place and someone figures out a way to send in a payload that doesn't jump to a function that is in this code at all. It jumps to effectively, it provides code and jumps to itself, and that code is usually to spawn like a shell or execute a command like on the system. So that's what shellcode is. So this is very much a different, it's a departure from what we did in the past. And this is where I did not want to do this in 64-bit necessarily, but I will definitely try. So first I'll just build it. Well, they can break it over the internet because, like, for example, I don't know, probably at some point this stuff wasn't super well known, like this exact thing. And so this code could literally be reading something like the login, right? Maybe you wrote a program and you exposed it to the internet, and this was a login function, and you gave a buffer of 128 and you said printf, enter your username. Maybe, or maybe, so like if there was a login, right? If I just was given some login prompt and I threw, right? Like we just saw, if I throw a bunch of A's at it, if that broke a program, if I gave like a login password of A, 2,000 times and the site crashed or the, whatever, you kind of could actually get a sense of maybe what's on the other end, right? So yeah, it helps if you have the source code for sure. That makes this like a fast thing. But if this code was exposed on the internet in some way, I think you would still basically see the service go down, right? You could crash the service, and then you would have like a sense of, oh, I somehow have a way. Basically, anytime you see a segmentation fault, right? Yeah, no problem. So, I'm going to try to get started on this one. It is a little tricky. I'm going to have some trouble, I think, but it's okay. So we'll copy this over. Oh, I already did this. Great. I did not define the level name, though. do I have like another version of GCC? Because I really don't want to do. $64-bit if I don't have to. Out S5. Ha. Okay. I don't know what's going on in this VM. I was doing something for possibly another thing I was gonna do, because I wasn't sure if I wanted to do this or something else, and I did something to my GCC compiler. But we did get it into 32 bits. That's good. This might be a lot more doable now. Okay, so actually the breaker thing works again. So that breaker. Oh, I shouldn't have I renamed it. I shouldn't have done that. So I'll just do that again, where I just make a massive something that we know is gonna break. Just to get a sense of where it breaks, at what offset. And it is gonna call start level, and it is just gonna get that. So actually, let me disassemble start level, where you guys can probably see it. Call gets. We'll just stop right after that probably. So I'll run it one time first. It's gonna crash. And I think what I want is to stop right there. Okay. Oh, you know what I should do? I should open a gray background. You can then you'll be able to read it better. The wallpaper is not helping me. Okay. So basically all that changed now is you'll see ESI, EBP, EDI, EIP. That's just because I changed it to 32-bit, so these registers are just a bit smaller than they were before. Before they were 64-bit. So it looks like we do overwrite the instruction, the register holding the instructions, and it's at that. So if I were to continue, this is gonna segmentation fault, and we would say offset equals breaker dot find, and it's bytes. It's probably a much larger. Yeah. This is why I need to send in 4096. This is not the same as last time, because now we're trying to really break the program, jump completely. It's not at all in the source. I can open. Phoenix stack 5. So yeah, we're trying to do something very different, so I need to send in a lot more bytes. I'll just leave it at that. But we know now that, okay, if I send in 3,824 characters of nonsense, I can actually overwrite control. So I think what we want to do, so they want us to see if we can basically execute a shell. So the first thing I'm gonna do, actually see if we can pause the program without it being intended to, right? So what I'm gonna do is I'm gonna send in 3824. So the X90 basically just translates to do nothing. And then I'm gonna send in CC. So that's the instruction for a breakpoint basically. Breakpoint. So hopefully if we got this 3824 address right, we can actually run this. So it didn't quite work. I shouldn't be looking at ESI. I should think I need to be looking at EIP actually. Let's run breaker again. So the thing with all the junk in it. And this is too late, or is this okay? I'm trying to break it here. Is it not breaking there? It is. So I guess I was expecting this cyclic pattern to end up here. I'm a bit confused. So this address doesn't exist. This is just nonsense, I think. So this is where the stack pointer is. So we caused a segmentation fault, but how do we... So if I for example put in a test address of start level, could I just make this loop forever? Like, will it jump here? Confused. Okay. So that did work, ironically enough. But I think the problem is we need this value. So we need to fill the whole sort of stack frame basically, because these things all work together, right? Like the instruction pointer, and the actual address, or this holds the actual instruction, and the stack pointer are all kind of important. So I think what I need to do is put I think this is the address of our actual shell, like our code. I still just want to put a breakpoint, to be honest, just to see if it's working. This isn't stopping where I would expect it to stop. So I'll put a break before here too. Second point. Let's try it again. Okay. Oh, so that address is something. Okay. So this is what it looks like just before the call to gets here. Right? And this stack frame so then we set in a bunch of junk. It crashes. That's what I'm confused about, though. Is EIP. Is this pointing to something in the code we sent? Um, it doesn't look like it. A little confused, I gotta admit. I don't think this is real. How to get into this? Maybe I need to... Okay. I have a thought. I know, vaping's bad. I did smoke cigarettes at one point. So, you know, it's a maybe better alternative. I do not condone, or I don't know. I wouldn't recommend it to anybody. Um, yeah. uh, so I think what's happening here. Yeah, you know the struggle. Yeah. I'm hoping that, you know, by the time I'm like 40 or 50, cigarettes and vape. I the price of vapes got so high. I actually considered buying a pack the other day. It's bad. It's bad. But yeah, I was gonna say like maybe by the time I may or may not develop issues with my lungs, we can just grow new lungs. I don't know. I guess the future we'll see. Okay, so the stack pointer's here, and the yeah, that's how I'm oddly optimistic, I suppose. I'm missing something. So this has that. Okay, EIP has that full buffer. No, wait. Hold on. I want to run. Just want to see what happens. Okay, yeah, so it doesn't break even if I do it outside of GDB. This for some reason isn't looking the way I... This is the part that I... EIP is pointing to... P12X EIP. So is this in my... Right, it's so fun. So the problem is we are breaking the code, but we're not throwing it into anything useful. And I don't know if this is in the cyclic. Yeah, it's not. That's what I'm confused about. Because I thought the way that this works was you basically send bunch of shit, right? And this effectively overflows, I thought, EIP. And then address, right? So I thought at that point this would actually have this. And then I thought you append it with the actual shellcode. That's true. Maybe, because I did get a it did crash, but maybe this just simply isn't large enough. I like that idea. Thank you. So let me just make breaker even bigger. Let's see. So okay. I think unfortunately I'm just gonna have to do a little bit of looking online, not at the answer, but at how this works, because I am forgetting. Stack Overflow controlling instruction pointer. Because that's the problem. That's what we're not doing correctly. Oh no, this is this is Protostar. Still though, it's kind of almost exactly the same. I don't want to do that. That's like a little too close. Because we're only changing ESI for some reason. Maybe that wasn't big enough? I don't know. It seems like a lot though. Alright, I think this might be, this is from 2011, so this is probably more generic. I don't think it'll. So bright, it burns my eyes. That's the problem. I'm not finding um I'm not finding an address. So right now I sent in 16K characters, and it looks like I've overwritten ESI but not EIP. Oh, it's so bright. Oh, the address of that. So, you can just copy any portion of this pattern, and then, because breaker is like a string in Python, we can use the find, or I guess it's like a byte string. We can do that, and it'll tell us. Yeah, exactly. So this is 3,824 characters into this. Why is EIP not being overwritten? It is at some point, I think. It's just before the first, it returns the first index, yeah. Oh, are you saying... Should I add? Maybe I should add to I should add... Yeah, that's 4. So maybe I should add 4 to this. Let's see if I get either like 90, 90. Oh, I think the problem was doing this again. Let's see. Let's see. Something's happening within gets. I feel like that's weird. Yeah, no, I got what you mean. I honestly did think that was. I think something could be going on with because or I just like way overdid this. Maybe it should be more like oh. Ah, okay. Okay, I overdid it. I overdid it. Yeah, 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 yeah. Okay, so here's what we're gonna do. Here's what we're gonna do. Instead of that massive pattern, this is gonna be a lot smaller. This is gonna be. We don't need help. That's okay. So I think this still generically is kind of true. Um, it's only 128. I overestimated what I needed to do. Um, yeah, I won't get into why I thought I need to get to such a large number. That can come up in other challenges. Uh, yeah. Anyway, so let's try only 256. Run breaker. Continue, continue. Awesome. So now we see we do have control over the instruction pointer, and it's at this offset. So we can find where does that start. So breaker.find cab. So it's 140. Okay, so now I should be able to force a breakpoint effectively by sending in anything 140 times plus try this. No. You're not allowed to play ads. Stop. Okay. Okay. So I need the address of where that starts. So I think okay. So I think now what's gonna happen is it should get overflowed, see this as a new address for the next instruction, which is actually pointing to the code that we're giving it, which is actually just to break. So CC translates to like trap, sig trap. So if I hit continue, not quite. Not quite. So the address was a little bit off, I think. Unless maybe it's a alignment thing. Try again. So it's gonna... That is the right instruction right there. Interrupt 3 is what XCC translates to. So maybe my address is just wrong. Maybe this D19C should actually just be D1A1. Because if I look at the raw memory there, oh, no, it should, let's see. Hey, it worked. Great, great, great. And we can sanity check this, right? So I can cat breakpoint into S5. Oh, I guess it won't work in the... But yeah. Yeah, because it's going to stop, but then not continue, so that'll break. But basically, we've gotten into the shellcode part. So now we have a choice of what to do. I think for simplicity's sake, I will reuse other people's efforts, just because shellcode is something that's pretty kind of its own field. Effectively, we're writing assembly code that's gonna be run. So we're basically giving precompiled instructions as a string and passing the address to that for the code to then run. If that made sense. Um, so, well, maybe I can't. You know what? I take that back. Let's see if we can do it the old-fashioned way. So I have something from a hack the box challenge, and I think oh, I don't have any. Oh no, do I have something for a shell? Test shell. Echo. Oh, this does a whole thing. Alright, you know what? Okay, it's fine. It's fine. We'll just do it the way other people do it. That'll be something I can look at in the future. I want to complete this goal of finishing all 5 in one sitting. So okay, there exists places where people have already kind of come up with all sorts of different shellcode. That's helpful for us. In this case, I'm gonna use Shellstorm. I think it's like probably the most well-known. It breaks it up because it's gonna be very platform dependent, right? Because at this point we're forcing assembly code, and so some of that assembly is going to be very platform specific, which is why I cared about doing it in 32-bit. So I'm going to look for some Linux. I might have already passed it. It doesn't need to be X. Well, it's not ARM. Let's see this. No, but see, this is RDI, RDX. Effectively, though, this is what I was looking for, right? So we're gonna basically create this at runtime. I wonder if I can't just... The links, yeah, they are pretty specific. Shellstorm, that's yeah. They're all kind of related in this sort of cybersecurity like realm. Like I think if you just Googled shellcode, Shellstorm would come up fairly quickly. Exploit.db is the other big place. That's where like all of the like as vulnerabilities are discovered, the proof of concepts will get posted there. But yeah, Shellstorm is a very specific thing. And the only reason I know is because I did this challenge. Well, this challenge and then there was a hack the box challenge that was kind of similar that you just saw a snippet of my solutions for. But anyway, so I'm going to see if I can just change this to... this might not work at all. But I might be able to just change these registers to... to their 32-bit equivalents, because Oh, this string might be bigger than 1, 2, 3, 4, 5, 6, 7, 8. No, I think it'll fit. I think it'll fit. Oh, Vim, you son of a bitch. Alright, so delete. Cool. So what we can do is I forget the NASM 32-bit. I think it's like I36. That's what it is. So NASM. I think that's the only thing I need to do there. And then oh no, it's G or F. What's the NASM format for this? Well, I don't know if I need to do all. Well, I should do. Yeah, NASM 32-bit. 386. Oh, it's okay. I was way off. So NASM.f elf32. And we want so I couldn't just take that shellcode from what I had found. It's always risky doing this. But I'm gonna take shellcode from the internet and just try it. Luckily I'm in a VM. Okay. So let's see if this works. We got our no ops. So that people call that a nop sled because we're effectively kind of creating a region of as we're smashing the stack, we're giving a bunch of do nothing instructions, so nothing happens until it hits this address, which points to our actual code itself. Plus a whole bunch of nasty shellcode. Did this get... Also, welcome in if you're new here. I think I saw a new viewer. We're just taking a look at... I'm trying to speed run through all of the Phoenix exploit education challenges, specifically the stack section. So we started with stack 0, kind of got through that pretty easily, and now we're having a little bit of resistance at stack 5, but I think probably be able to figure it out hopefully. Yeah, so welcome on in. So I just need to add this and the 80 at the end. So that's where, so 2F, 2F. Oh, no, this is all wrong. 90 times 140 plus this address plus, let's be more careful this time. Oops. Cool. And we'll call it exploit. I don't know if it's gonna work because the shell code is just sort of pulled from the internet. But let's see what happens. So bright lights, that hurts. Okay, so let's run exploit. Okay, so now when we hit that return instruction here, we're now in the actual shell code, and it looks like it might, oh, it left before we could get there. Let me see. Maybe this needs to be massaged a bit. Okay. So we're gonna leave return. Okay. Okay. So it's pushing bin sh on the stack. What was the first instruction? That is not what I saw here. It did push bin sh. Let's see. We're so close. Another one with no no assembly, so I don't know what it's gonna do. It's a little dangerous. Here we go. I don't like this. Alright. Oh no, it's assembly. X4. No, that's not gonna work either. I don't want to just blindly try these. That's the problem. It's a little... okay. ASM call exec v bin sh 32-bit. Okay, this time they gave us instructions at least. Okay. I will try this one. That also looks kind of similar to what I think I would probably end up doing. Yeah, it's in a VM, it's safe. It's also just, I just don't like blindly following someone else, you know. That's why I didn't fully understand how to redo this in the first place, I think, to some degree. But I think in this case, I do. I just don't, I want to save time not writing assembly code necessarily, because we're so close. Yeah, it's safe enough. Alright, let's get that in there. Write it. Exploit. We can see this. Okay. So we're gonna hit that return instruction. Oh, maybe I need to. So the first thing it did was XOR EAX. But I'm seeing. So I might have got this start address a little off. It might, yeah. Yeah. Okay, that's okay. I need to go back to what I was doing before with this. 19C. So as we change the size, I think, of the shellcode, the offset we jump to may need to change, as I think what's happening. Continue. This address is definitely wrong. Let me try this. So I should be able to find where 31C9F set, where that is starting. So the return is pointing to oh no, I can't do that. Oh. E1 F7 C9. Is that what's E1 F7 C931? Okay. So I might be off by 4 again. I might be off by 4 again. Let's see. There we go. Okay. So we know that we wanted ECX to be the first instruction because that's what... Oh, it's EAX, not ECX. Weird. I might still have something a little fucked up. That won't really do anything though. Alright. Alright, cool. So that did work actually. So if I exit out of this and I cat exploit into S5. Oh. Wait. That's weird. I'm surprised it doesn't work here though. Huh. Interesting. But it should. Ah, so it called it, but it had bad. Didn't exit cleanly and stuff. Interesting. Interesting. Okay. I think to do this right, I'm gonna have to just write my own. Most of this worked though. I don't know that I need to do a lot differently. So I think we need to treat the registers a bit better. This push instruction could be part of the problem. What time is it? 10:15. Should I save this? Just complete it. Let's try to complete it if we can. Okay. So this is close enough that it should, I think, generically get us almost all the way. That's a good question. Is there... I don't think this actually has much in the way of help. They kind of generally just tell us, like... Alright, I'll show you. They do tell us that we need to call exec VE. Yeah, so we did this. Don't feel like you have to write your own shellcode just yet. There's plenty on the internet. Yeah, that's true. I guess maybe it is easier just to do that, huh? Just feels like cheating, man. Plus, then we get to this, right? Like now we're at this point where it did call. Like it was about to pop a shell, but it didn't do it with the right. Like the registers were kind of trashed. Okay, so I'm gonna look at something I had done for a Hack the Box challenge, because I think I have some code for doing some of this. So this, for example, is going to be helpful. And then so I mean, let's just try. I can try to copy theirs. Oh, it's got a lot of comments and stuff too. That's nice. Oh, so close, so close. Oh, and then oh, yeah. Okay. What did I call? this one's better. Actually, I'll call it Shelly 2. Just because the other one did something too. Oh, is there something with the syntax? Yeah. Let's see. There's a few channels. I have to think about it, to be honest. Well, actually, so I will have a so next time I come on, I'll post a link to a Discord community I started, and in that I'll have a bunch of resources on like programming, cybersecurity, other topics, and then it should be a little bit easier to share those kinds of things. And I think what I'm going to do is actually put a pin in this here, because we really did kind of get where I wanted to. And I think maybe what I can do is do a separate thing entirely on actually writing my own shellcode and then passing that to this instead of just Googling around for shellcode, because that might be a sort of interesting twist on how to solve this last part. But effectively we did get there. I mean, we totally controlled the EIP pointer to point to user bin dash, which did start executing. It's just that we didn't clean up the registers, so it looks like it didn't quite finish the way we wanted it to. So yeah, I think next time might not even be maybe I'll go back to hack the box boxes or challenges. Maybe we'll finish this. I definitely will do that at some time with like custom. We can figure out how to write custom assembly to create our own shellcode to finish this. Yeah, I'll share a Discord, have more kind of conversation. Yeah, so thank you so much for joining me again, and I hope you have a great rest of your day, night. I think you mentioned day. Yeah, take care, have a good one. I'll probably, yeah, I'm glad we got somewhere. We did struggle through it. We almost really got it, so we made a lot of progress. Very cool. Yeah. So, alright, have a good one, and I'll probably be back on, if not, probably this weekend. So, yeah, just stay tuned for more stuff. Yeah, like you mentioned, YouTube, I'll probably, branch out to YouTube channels, and I can share resources and stuff for sure in Discord. Yep, cool. Yeah, you too. Have a good one.